and thickness both are same, so it is a square key which we are using. Now we'll see the length of the key in each shaft. How much should be the length of the key in each shaft? What does that mean? As you all know, I have the muff and the shaft, so the key will be fitting into the shaft here like this, and then that will fit into the muff or sleeve. So this part, in this part, what is the length of the key which is going into the shaft, each shaft? Length of the key in each shaft. See, here is the length of the key in each shaft. So the key will be fitting in both the shafts like this. The key will be fitting in both the shafts in this way. So what is the length of the key? This part, length of the key in each shaft, we'll be finding out. That's a very simple formula here. So length of the key, small l, is equal to capital L by 2. What is the capital L? We just saw here. We just found out capital L, 195. Take the same thing here. Capital L by 2, 195 by 2. That is 97.5. So it just means that the key will be halfway inside. So the total length of this, take the half of that for muff coupling. You can see here 195 by 2, that is 97.5. So now you have found out the values of the thickness, width of the key and the thickness of the key. Both are same, and then the length of the key in each shaft. So you have obtained the three values. Now we have, from this, in this procedure you can see we have found out the width, thickness and length. So we have found out the width, thickness and length of the key. So once you know that, as the last 2 points in this, check for shearing and crushing stress. So you can see here, first let us check for shearing. What is the shearing? As you all know, when the key and the shaft are fitted into the muff coupling, so when it rotates, when the shaft rotates in this way, the key, this key can shear off in the center. The key can shear off. That is the first option. Second option is the key can get crushed when the shaft rotates, and when there is huge amount of torque being transmitted, the key can either get crushed or it can get sheared. Sheared is it can get cut in the center. So the two options are shearing and crushing. Just remember, shearing and crushing. Shearing and crushing are the two options, two things which can happen here. So first we need to check for the shearing and then for the crushing. Two things, shearing and crushing. Just remember this, shearing and crushing. So we'll just see the part here. Check for shearing in the key. How will we do that? This formula is given in a handbook. You need not memorize that. So just put the value T is equal to L into W into tau S into D by 2. So the values are already found out. Just put the values. T is known to you. L is the length here. This is the amount of length which will be in each shaft. So we need to take 97.5. And width you already know, 18, which you found out here. The width and thickness both are same. The width and thickness both are same. Just put 18 here. Tau S. Now we need to find out the shear stress in the key. So tau S is unknown. We need to see how much is the shear stress. So tau S, write the tau S here. And D by 2, that is 55 by 2. Small d by 2, that is the diameter of the shaft. So it is in this diameter where the key fits. So 55 by 2. You can see here all these values. Just I don't know the tau S. Keep this tau S here. Transfer all these to the other side. So it becomes 2 into the torque value divided by 97.5 into 18 into 55. See, 97, 18 and 55 go down, 2 and this torque go on top. So you get the value as 22.8 Newton per millimeter square. Just here, after solving this, you will get a value. If you solve this in the calculator, you will get 22.8 Newton per millimeter square. So once you have obtained this, this value is the amount of shear stress which will be encountered. This is the amount of shear stress which will be encountered by the key. So remember this value. We'll just see an important point here. The last part of the problem, 22.8, which we just found out here in the previous page. Shear stress induced in the key 22.8 is less than 40. Is less than 40. So why we need to see that? As I just told you in the question, it is given the shear stress in the key, shaft and key is 40. So I just need to check whether the value is less than 40 or no. So I have obtained the value, it is less than 40. So the key, the sharing of the key is safe, that it will not share. So the key is safe from sharing. Let us see the next part, the last one. As I showed you in the procedure, the last part is the crushing stress. We need to, now I checked the sharing, so now I'll check the crushing stress. So the same thing, check for crushing or crushing stress in key. This is the equation which is given in a handbook. So just here it states a T is equal to L into T by 2. Why T by 2? Because it can crush from the center, the thickness will be crushed. So into sigma C. What is sigma C? That is the crushing stress. We need to find out the crushing stress. So just put sigma C as it is, and then D by 2, that is the diameter by 2. T, write it as it is. L, that is the length of the shaft, length of the key in each shaft is 97.5, write it as it is. T by 2, 18 by 2. Sigma C, write sigma C as it is. D by 2, 55 by 2. So write it as it is, write the things as it is. I don't know this value, I need to find out whether it is safe or no. So just keep this here as it is. Take this, all the things to the other side. 2 and 2 go this side, so it will become 2 into 2, and this torque value, and then 97.5, 18 and 55 written as it is. So once you calculate this in the calculator, you will get 45.6. So this is a very important point here. This crushing value 45.6 is less than 80. Why 80? Because in the question they have told you that for plain carbon steel the crushing stress should be less than 80. It should be 80 or less than that. So value is obviously less than 80, way less than 80. So I can finally write here my shearing stress is 22.8, which is less than 40. Sigma C, that is crushing stress, is 45.6, which is less than 80. So both the values which we have obtained are less than the allowable stresses given for the material. So finally we can write, since the induced stresses are less than permissible stresses, the design is safe. Design of the coupling is safe. Finally you just have to write this, the design of the coupling is safe. If these values are more, then what you can do is you can increase the values of the material. You can increase the thickness, you can increase the width or any other diameter which will supposedly make the design safe. So just let us go through the procedure once. Procedure method for design of muff coupling. The first thing is design of shafts. Design of the shaft. So first you have to design the shaft. How? First you find the torque. I'll just go through whole thing once more. You will have given the power. So you have the power here. Use the power, find torque. Take the torque, find the diameter. Use this diameter, then go for the design of sleeve or muff. Using this small d, you can find this capital D. Use this capital D and keep it as it is the value. Then take the L, use this same thing, small d, and you find the L length of the muff, and then check for shearing. Then go for the key. In the table you will get the values directly. Use that values to find the other checking of the shearing and crushing, and these values you get, and then you check the shearing of the key, and then after you find the shearing, you just have to find the crushing in the key. So finally, if the values are less than the permissible values, the design is safe. So let us see here in short, once for all, procedural method for design of muff coupling. First one you have to do design of the shaft. I told you design, first find torque. Take the power, given power value P is equal to 2 pi nt by 60, find the torque. Take the torque, find the diameter, that is 55 or whatever a small diameter of the shaft, you will get a value. Take the diameter, you find the diameter. Once you find the diameter, use this diameter and go for design of sleeve or muff. In that you will be finding the outer diameter, that is large diameter, outer diameter of the muff. And next one, you will be finding the length of the sleeve, and then you have to check the shear stress. After that, go for the key. Width and thickness will be given in the table. Then find the length, and then finally check for shear stress and crushing stress. So if these values 1, 2 and 3, all these three values, if they are less than the allowable stress, then your design is safe. So this is the procedure. Just remember here, use your 3 fingers. Design for shaft, muff, key. Shaft, muff and key. These are the 3 points. Shaft, the muff and the key. So in the shaft, torque, first thing is torque, then the diameter. Only two options, torque and the diameter. There will be a different question. Sometimes the question will be twisted. That time we will have a different procedure. A small change will be there in this part only. The rest of things will remain same. So just you have to remember three things: shaft, muff and the key. Design first the shaft using the torque and you get the diameter. Then you go for design of the sleeve or muff. You find the dimensions and then check the shear. Then again the key, find the dimensions, check for shear and crushing. So the 3 points here are shaft, muff and key. So just remember these 3 points. You need not memorize anything here, or you need not practice too much thinking that is a very difficult subject. It is not so difficult. You just have to remember the key points, and using those key points you will be able to solve it easily. So remember this procedure: shaft, first is design of shaft. As I told you, first you design the body, then the head, then the legs. Shaft, muff and the key. As I told you, first the body, the head and then the legs. Same thing here. The shaft, which is the main part, then the sleeve, the outer part, then the key. So first the shaft, torque and diameter. Using that you find these two things. Then you go for shear stress. Then again finally the key, width, thickness and length. You will obtain them. Finally check for shearing and crushing. So this is the procedure for design of a muff coupling. We will discuss another different type of problem in the next video. Thank you.